why your biological age matters. I've been measuring biological age in high-performing executives for years, and I need to tell you something that might shock you. I've tested marathon runners whose biological age was actually older than their chronological age, and I've seen 50-year-old CEOs with the cellular age of a 35-year-old. So your birth certificate, in many ways, is lying to you about how fast you're actually aging. There's so much buzz around biological age testing these days, but here's what the companies selling these tests won't tell you. Most people are completely misunderstanding what biological age actually means, and more importantly, what you can actually do about it. Now, I'm passionate about longevity medicine, and I work specifically with high-achieving professionals who want to optimize your biological age. By the end of this video, you're going to understand the fundamental difference between counting birthdays and measuring how your body is actually aging at the cellular level. And I'm going to show you the 3 biological clocks that are ticking inside your body right now, and why only understanding these can help you extend not just your lifespan, but more importantly, your health span. Because here's the thing, advancing age is the single biggest risk factor for any chronic disease, including cardiovascular disease, cancer, and neurodegenerative diseases. But what if I told you that aging isn't just about the number of years you've lived? It's a complex biological process that you can actually measure and influence. And what I'm about to share with you is based on Nobel Prize-winning research from 2009 that completely changed how we understand aging. Scientists have identified the molecular, cellular, and systemic mechanisms that drive aging, and they're referred to as the hallmarks of aging. Now, originally, in 2013, there were 9 that were proposed, but recent research has really led to a consensus on 12 separate hallmarks that intricately affect the way and the rate that we age. When I was in school, we were taught that telomeres were just junk parts of your DNA because they didn't code for anything. But in 2009, 3 scientists were awarded the Nobel Prize for uncovering the role of telomeres in aging and disease. And we now know that telomeres are protective tips on our chromosomes that protect the integrity of the genetic material. Think of telomeres like the plastic tips on a shoelace that prevent the shoelace from unraveling. Each time a cell divides over your lifetime, the telomere sacrifices a piece of itself and becomes a little bit shorter. When they become critically short, cells enter an irreversible state called replicative senescence, which is accompanied by changes in cellular function, morphology, and release of inflammatory molecules. These zombie cells accumulate with age and are linked to aging-related diseases. This isn't just theoretical. There's a strong linear inverse association between telomere length and most chronic degenerative diseases. As telomere length shortens, your risk of cardiovascular disease and death goes up. And this is independent of other risk factors like age, cholesterol level, or even inflammatory markers. So telomere length is like a ticking biological timer inside your cells, reflecting something deeper, some type of integrated cellular stress that gives us profound information about your actual health, not just how many birthdays you've had. In patients who already have coronary artery disease, one study found that those with short telomeres were at a significantly increased risk of death from all causes and hospitalization for heart failure. This was independent of other risk factors. It really suggests that telomere length is reflecting something deeper about integrated cellular stress. There was a study about 10, maybe 12 years ago, where researchers looked at telomere length in women under stress. And in this particular study, the stress was taking care of a special needs child. What they found was that the women with the highest degree of perceived stress had shortening of their telomeres consistent with an additional decade of aging. That again is independent of any other risk factor. This was just stress alone. And while regular, intense exercise can contribute to maintaining telomere length and reduce cellular aging, here's something that might surprise you. And I know, a lot of marathoners don't like to hear this, but over the years, when I've measured telomere length in people who perform multiple, repeated, long-duration exercises, the telomeres are typically shorter than expected for their age. Now, even overtraining, particularly in long-endurance events, creates tremendous oxidative stress, and if you're not giving yourself adequate recovery, that can cause prematurely shortened telomeres. But on the other end of the spectrum, if you look at healthy centenarians, that's people living to 100 without major age-related diseases, they have significantly longer telomeres. In one study, the average telomere length of healthy centenarians was 5,770 base pairs compared to 3,650 in the unhealthy centenarian group. This tells us that telomere length is an indicator of robust health span not just longer lifespan. And that's really what we all want, the years that you continue to feel healthy and function well. The other significant disease associated with short telomere length is your risk of getting cancer. When telomeres are short, that can lead to chromosomal instability and the type of changes that can lead to cancer. When you look at studies and groups of people with the shortest telomeres, they have a 3 to 4 times higher risk compared to same age people with the longest telomeres. And that's particularly so for aggressive cancers, gastric cancer, lung, and ovarian cancer. Now, if we zoom out from the physical chromosomal protective caps and look at the epigenome, right? Your genes don't change, right? Your genetic profile stays the same, but the epigenome is sort of the software of our genes. It refers to chemical modifications on the DNA called methylation that control how genes are expressed. Think of it like putting sticky notes on the DNA to say, read this or ignore that. Some genes are designed to be on, some are designed to be off. If that expression is changed epigenetically, that's when you run into problems. These methylation patterns change predictably with age, and that's where DNA methylation clocks come from. The most well-known is one of the early clocks, the Horvath clock. These epigenetic clocks can predict all-cause mortality and disease risk more accurately than just knowing how many birthdays someone has had. There are second and third generation clocks now that are more accurate at predicting or associating those methylation changes, not just with age, but with risk of disease in individual organ systems. These methylation markers are another way to measure biological age, and they can predict all-cause mortality and many disease risks that are more accurate than just knowing how many birthdays someone has. Now, if you're a high-achieving professional who wants to take a data-driven approach to optimizing your biological age, I work specifically with executives, founders, and entrepreneurs who want to go beyond basic health metrics. I'll put a link in the description if you want to learn more about precision longevity protocols. The third piece is energy production through mitochondrial function. Your mitochondria are the power plants of your cells, and mitochondrial dysfunction is what we call an antagonistic hallmark, meaning it's the consequence of accumulated damage elsewhere. There's a molecule that's crucial in energy production and has a lot of buzz lately, and that's NAD+, vital for mitochondrial health and acts as a helper molecule in hundreds of metabolic processes. NAD levels are tightly linked to sirtuin genes, which are considered longevity genes. The sirtuin enzymes need NAD to function properly to regulate DNA repair, inflammation, stress resistance, and insulin signaling. NAD levels decline as we age, but recent science shows it's not primarily a reduction in the production of NAD, it's accelerated degradation by enzymes that become more highly activated as we age due to inflammation and the accumulation of senescent cells. The question is, this is great. We can measure biological age, but what can you do about it? Well, for the epigenome, telomere length, and mitochondrial function, there are things you can do. Sometimes very simple things that we already know are healthy, but now we have the biological underpinnings to understand why they are healthy. Top of the list, exercise. Maintaining aerobic capacity is very important. Incorporating high-intensity exercise, incorporating strength training to maintain muscle mass, all very important. But remember that even with something as universally beneficial as exercise, it's not infinitely beneficial. There's a point when more is just more and can be counterproductive. Eating a healthy diet, and for most people in the United States, that means adding in more fruits and vegetables and reducing refined grains. My philosophy is to start with the Mediterranean diet because that's been proven to reduce cardiovascular disease, diabetes, cancer, and dementia risk, and promote maintenance of telomeres. Introducing some degree of time-restricted feeding because what, when, and how much you eat and don't eat is key. Studies have also shown that consuming high-quality fish oil, as omega-3 fatty acids, DHA and EPA, slowed the rate of telomere shortening over a 5-year period. Getting adequate restorative sleep is critical. Managing stress is critical. Remember that study about stress aging women by a decade? These aren't just lifestyle suggestions, they're biologic interventions. Now, maintaining optimal NAD levels supports healthy aging and resilience by enabling enzymes to perform their roles in energy metabolism and cellular repair. But there's something I haven't told you yet about NAD+, and why those expensive NAD IVs that everyone is getting might actually be a waste of money, or worse, may increase future health risks. But here's what's crucial. Biological age testing in and of itself is not something I would recommend in isolation. It has to be done in coordination with everything else going on in your body, because the testing is just not accurate enough by itself to gauge what clinical interventions you may need. So remember, your chronological age is just counting birthdays. Your biological age is measuring the actual state of your cells, your tissues, how worn down they are. Now that you understand what biological age actually means and why it matters more than your birth certificate, you need to know the specific protocols for optimizing each of these biological clocks. In my next video, the NAD plus protocol that actually works, why IV therapy is wrong, I'll show you exactly how to optimize your cellular energy production and activate those longevity genes we talked about. Click here to watch it now.